RR. I'm mathematics and mathematical literacy teacher at Rondebel Secondary School. So now, as we all know that we are under this pandemic COVID-19, we are trying by all means to make sure that we do what we can in order to make sure that learners catch up with the work that they are losing out as the lockdown continues. So this is the project by Maduna Kabinde project. So we are trying to make sure that we at least do revisions and we also teach so that learners can get as much as they can while they are at home using their own gadgets. So we are now going to do revision on paper 1, question 1, mathematics. This topic is one of the topics that many teachers and learners, they take it for granted. And when we are at the marking center, we realize that many learners, they are lagging behind on it. And then, so that is why now we have to start by revising it and trying to make sure that we drill them to learners so that learners may understand. So we are going to take a look at the November paper 2017, which was written by those learners that were writing matric in that year. So we will start with question 1. So question 1 of paper 1, it's all about algebra or general algebra. So here it is solve for x, which is 1.1.1, it's x squared plus 9x plus 14 is equals to 0. So that is the general algebraic equation. Then with this one, we use factorization to solve for it. So what is happening is we look for the factors of the first term and the factors of the third term. When we have those factors, we multiply and we add. They must give us the middle term. So the factors of the first term in this case, it's way too easy because it's only x squared. So that one, it means those factors are not going to change. It will be x and x in both brackets. So then the one that now we need to find out as to which ones when we add can give us the middle term are the factors of the last term. In this case, happen to be 14. So if we look at the factors of 14 in pairs, we have 1 and 14. We also have 2 and 7. So those are the factors that we have for the last term. So if we look at the first term, if we add 1 and 14, it gives us 15. But when we say 14 minus 1, it gives us 13. So it won't give us the middle term. But when we come to this other pair, which is 2 and 7, when we say 2 plus 7, it gives us a 9. And in this case, the signs there as well, we take them into consideration, whereby we are having a positive and positive. So it means that both our factors should be positive. So when we add 2 and 7, it gives us 9. So it means we are going to have plus 2 plus 7. So then that is what we are having. So these are the factors that when we multiply, we will still, and add, we will still get the equation there. So what is happening here? Now it is x plus 2, it's equals to 0, or x plus 7 is equals to 0. Whereby when we transpose, now it changes the sign. It will be x is equals to -2 or x is equals to -7. So that's the solution of that equation there. So that is how we normally deal with it. But in most cases, we skip this because if you look at this one, it was having 2 marks. So 1 mark come for factorizing and then the other mark come for the final answer, which both answers or values of x should be correct. Then that is where you get the other mark. So then before we go to the next one, I want us to do as much as we can to exhaust this one because it doesn't only come in this way. Sometimes it comes in another fashion, the same question. It may come as x plus 1 and x minus 2 is equals to 0. So when it comes in this way, it's already factorized. So what you need to do is just to say this is equal to that and that is equal to this, which this one in most cases will have only one mark. So you will have x is equal to -1, because when we transpose that, it's gonna be negative, or x is equal to +2. That was negative and then it become positive. So that is how the other one will come. So this one, it should not confuse you with another one that can be the same. X plus 1, x minus 2 is equals to 4. So this one is because here is 0, so then your answer is going to be just like that. But with this one, it's not a 0 here. So what we need to do is to find the product of this. You transpose 4 and then you refactorize. So this one in most cases come with 3 marks. So where are the marks coming from? So with this one we use what we call FOIL method. This one is not a rule, it's just a method. FOIL, F for first, like meaning that the first term in the first bracket and the first term in the second bracket, or meaning the out terms. The out in the first and the out in the second, whereby we are talking about the x and the -2. And then the I for in, we are talking about the in the first bracket and in the second bracket, which is 1 and x. And then the last ones, so we are talking about the last in the first bracket and the last in the second bracket. So what we do is we just say x times x, it will give us the x squared. And then we come now for out, we say x times -2 is -2x. For the ins, so we start with x and x, and then x and -2. So we come for 1 and x, which is x. And then now we go for the last, which is 1 and -2, which is -2. We transpose the 4, which is -4, is equals to 0. So now, when we have it like that, we must now add the like terms so that we have it in standard form. Standard form, we are talking about when it is a, it's almost like ax squared plus bx plus c is equals to 0. So this is the standard form in which the quadratic equation should always look like. So what is happening here, it's the x squared, it's only alone. So then we are going to have it x squared. But the x's, they are 2, which is -2x and positive x. So -2 plus 1, it's going to give us -1, which is -x. And then we also have the constants, which they are 2, which is -1 and -4, -2 and -4. So -2 minus 4, so the signs are the same, and then we are adding, and then but retain its sign, which is -6, is equals to 0. So the first mark will come for that standard form. So you will have to work out from here, and then you come there, and then this step doesn't have mark, but the mark is there. But it's very crucial to have it because at least it will make you not to make mistake. And then now we come for the factorization. Factorization again, in this one, it's good because again, the first term, it's only an x squared, which is the factors there will just be x and x. So we will have our x in the first bracket and x in the second bracket, and then it equals to 0 there. Then now, the factors of 6, they are also having 2 pairs, which is 1 and 6, and 2 and 3. But the signs there, it's negative here and it's negative here. So it, like, we are governed by the sign of the last term, which is our constant. So if the sign there, it is negative, it means our factors, one should be negative, and then the other one should be positive. So that is how those things are working, or that's how we factorize. So then, if it is like that, we check the middle term. The middle term is -x. So the ones that are going to help us or to work out the factors of 6 there is 2 and 3. So then it means 3 will be negative, and then 2 will be positive. Because when you say -3 plus 2, it will give you -1. So that is why and how these things are going to work. So then you get the second mark there for factorizing, and then you will get your last mark for saying x is equals to +3 or x is equals to -2. So that is how, in way in which the first problem in question 1, paper 1 of mathematics may come. It may come like in the standard form. It may also come as factorized. It may come in a way in which this one now you have to find a product and then you add down, you write it in standard form. Then after writing it in standard form, you factorize, then you find the solution. So the other one that may come, which I have seen in many previous papers, that this problem come in, it is in this way, whereby now we also have it sort of like x into x plus 3 is equals to probably, let's just say 10. Then even this one, we cannot say it is x is equals to 10 or x plus 3 is equals to 10. No, what we need to do is to first find the product of this one, and then after finding the product, then we transpose 10, and then now after transposing 10, we now write it in standard form. And writing it in standard form, that is where we find or we get our first mark. So what is happening is, this one is what we call, we use the distributive law, whereby the coefficient will multiply every 10 inside the bracket. So whereby we will say x times x, it will give us x squared. And then we come to x times 3, it will give us 3x, then we transpose the 10, so we are having negative 10 is equals to 0. So the first mark will come there for writing it in standard form, whereby now we have it as ax squared plus bx plus c. So in this case, our a is 1, our b is 3, and then our c is negative 10. So then when it's in standard form, again, we are looking at the sign of our constant or the sign of the last term. Then that sign is negative, so it means our factors as well are going to be negative and positive, so that when we multiply, it will give us the negative 10 then. So the pairs of factors of 10, we have 1 and 10, we also have 2 and 5. So if we are having 2 and 5 now, how do we go about writing it in the factor form? We will have it as x, as I said earlier on, that if here the coefficient is 1, then it means the factors are just the same as just x and x. And then now we are coming to this one. We said those pairs that will, the pair that will give us the middle term is 2 and 5. So we can just say 2 and 5. So then we look at the sign of the middle term. The sign of the middle term is positive. So if we make 5, because it's bigger than 2 positive and 2 negative, if we say 5 minus 2, it's going to give us a 3. So that is how that one it's working. And then now when we have it that way, now at least that is where your second mark comes in, and then the last mark will come for getting the correct answers or the solutions of x. So we are having x is negative 5. So it was negative here, it become positive. It was positive here, it become negative. That's when we transpose. So that is how this question may come. It may come in many formats and in many ways, but this is in which generally the first question comes. So when it comes in any way, then this is how you deal with. So if it is in this way, you have to write it or do it in standard form first, which it came to be x squared plus 3x minus 10. And then we factorize, then we find the solution. So that is where the 3 marks are coming from the first question of paper 1, question 1. And then when we move on the second one, it normally comes, they normally set up the one that we need to use a quadratic formula to solve for x, because you cannot easily factorize. So that one that you need to use the quadratic formula, like the 1.1.2 of 2017 was 1.1.2. It was to say 4x squared plus 9x minus 3 is equals to 0. And then they said that one, the solution must be left in correct 2 decimal places. So what is happening here is once they tell you that correct 2 whatever decimal places, it means that they are telling you that use the quadratic formula. So to use that quadratic formula, now it's to say x is equal to minus b plus minus b squared minus 4ac all over 2a. So that is the formula that should be used. Because this formula is given in the formula sheet at the back of the question paper, so you will choose it correctly. Then choosing it correctly, in most cases there is no mark because this formula is given in the formula sheet. So then, but the first mark comes when now you substitute. So this is A, this is B, this is C. So our B happened to be positive 9. So because of that negative there, we'll still say minus 9 plus or minus, then the B again is still 9. So get used to writing that in brackets and then you say square because of that square. Because sometimes it will come as a negative. So if you write negative, like let's say negative 9 squared, then your answer there is going to be negative 81, which is wrong. But if you put it in brackets, then it means it's going to give you positive 81, which is correct. So that is why it's always advisable to always write your b squared in bracket so that you don't calculate it wrongly. And then we have negative 4. Our A in this case happened to be 4, and then our C happened to be negative 3, and then all over 2 into 4 because our A is 4 there. Then now you get a mark for correct substitution into the correct formula, because if you substitute, even if you substitute correctly but in a wrong formula, then you are like that, it will not even going to be marked because we didn't use the correct formula. So then for correct substitution into the correct formula, you get a mark. Now we go on to now calculate. So we will have our negative 9 plus or minus. So that 9 squared is the one that gives us 81. And then now we come to this one, whereby we say 4 times 4 is 16. And then 16 times 3, but the negative and the negative makes it positive. So 16 times 3, it's what we call 48, because the 16 and the 16 is 32, then 48. So we are having plus 48 over 8, because 2 times 4, it was to 8. And then now we have our negative, and then we have that, and then now we have 81 plus 48, we are going to have 129. 129 all over 8. So then when we have it there, there's a mark here, there's also a mark for adding that which is within the square root correctly. So then when you have it added correctly, now that is where we have to use a calculator to find out as to what are those values when we now have it like rounding off to 2 decimal places. So then when we use a calculator, scientific calculator preferably, with either Casio or Sharp, then what you can have to have it in the natural writing way, and then you get what you want there. So then that is what we are going to have. We'll have negative 9 it's 11,374, the square root of 129. So then we will round it off to 11,36. So 11,36. Then we go on now to say negative 9 minus 11,36. It will give us negative 20,36 divided by 8. And then we get negative 2,55. And then now we go again. We have to say now that negative 9. Negative 9 plus 11,36 equals to negative 9 plus 11,36 equals 2, then divide by 8. Then it's positive 0,30. Then because they were saying it's round your answer to 2 decimal places. So this is the only one way in which you can deal with this one. But as well, this can come in the other formats like this one, whereby first, before you substitute into the formula, you have to write it in standard form. So after writing it in standard form, then that is where now you get it that way. So then, but if ever it comes this way, it means first you must write it in standard form. The standard form, which I said it is ax squared plus bx plus c, so that you at least have your b, your a, and your c. So that then when you substitute, then you get it the way that it should be found. So that is how the 1.1.2 normally comes. So if it comes in any other way except in the standard form, first rewrite it in standard form so that when you substitute, at least you know where your A, your B, and your C should be written and how are they. So then that is how the 1.1.2 comes in. And then now the other one that comes, sometimes it comes in many other ways, but it's the one that we are squaring both sides in order to get our solution. So that one, in this case, the one in the 2017 of 1.1.3, it was the square root of x squared minus 5. It was to the square root of x. So then, that one, what happened is, what we do with this one, we have to make sure that this square root is one side, and then the other ones that are without square roots, they are also in the other side. So in this case, this one happened to be the square root there and the square root here. So, but anyway, then what we have to do, the first mark, come for squaring both sides. So by making sure that you square, and then you also square here. So what is happening is, we know that if it's a square root and you square that square root will be gone, but the content inside the square root remain as it is. And then in this one, okay, the square root of x squared will be x, but we are having the coefficient there, which is 2. According to the laws of exponents, we know that for any base, and then with the power outside, then that power goes for those bases that are within the bracket. So it means the 2 will come for this base, and again the square will come for this other base. So meaning that here's 2 to the power 2, which is 4, and then the square root of x to the power 2 is x. So that is what we are having there. Then again we have to rewrite this in standard form. So how do we rewrite it in standard form? We are having x squared, so this was positive x, 4x, and then it's negative 4x minus 5, it's equals to 0. So then for squaring both sides, for right, like there's a mark, there's also a mark here. Then another mark you get it for factorizing. In this case, it's minus 5 and 1. So then because the factors of 5, it's only 1 and 5. And then negative 5 plus 1 will give us the negative 4. So then, when we have it like that, we have x is equals to 5 or x is equals to negative 1. So when we are having it that way, now in this one, what will happen is now you have to check which one will give us the correct or the right solution there. So because it's not everyone that always give us the correct equation there. So then we start with the 5. So if we substitute 5 here, we are saying 5 to the power 2, which is 25. 25 minus 5 is 20. And then the square root of 20 is 4 comma something. And then here again, it is 5. So then the square root of 5, it is 2 comma something. 2 comma something times 2, which as well can give us probably the same thing. But now before we check using calculators, we can now check with the 1. The 1 here is positive 1. So 1 minus 5, it's negative 4. So if it's negative 4, it's already up because the square root of a negative number is non-real. So meaning that now we are left with this one. So then if we are left with 5, so it means we will say x is equals to 5 or x is not equals to negative 1 because it's not going to give us what like, because there it will be non-real. So this one is the one that is correct because the answer for that is 4 comma something, so which is correct there. If you don't indicate this, in most cases here, there are 2 marks. There's a mark for having both correct, and then there's also a mark for now ruling out the other one or cancelling out the other one, that this one is not working for this equation, but that one is the one that is working for that equation. So it may also come in many ways, this one. So the other one, I said that this one may also come in another format, which could be the square root of 5 minus x, and then minus x minus 1, which are outside the brackets, outside the square root. So what we need to do is, first we transpose those that are not in the square root to one side. So we'll have the square root of 5 minus x is equals to, because the x is negative, when we transpose it become positive, and also it become the 1, it also become the positive. Then what we do here in this, we also square both sides. So when we square both sides, that's where the first mark comes for this question. And then now the other question will come. So the square root of 5 minus x squared, now the square root is taken off by that square, and then we remain with 5 minus x is equals to. So this one, it means that it's x plus 1 times x plus 1. Whereby, if it's x plus 1 times x plus 1, it means that we're having x plus 1, x plus 1, where we still have x, 5 minus x is equals to, and then now, this one we're still using the FOIL method. In this case, we are going to have x times x, which is x squared. X times 1, it's x. 1 times x, it's x. So x plus x, it's 2x, and then 1 times 1, it is 1. Then now we transpose the 5 and the x to the right hand side. So we'll have 0 is equals to, so this one doesn't have a friend. So the negative x, it will become positive x. So 2x plus x will give us 3x. And then this become negative 5. So 1 minus 5, it become negative 4. So now this is in standard form. So if it's in standard form, what we need to do, we factorize. So in this case, the factors of 4, which will give us 3, it's 1 and 4. So in the 3 is positive, and then it means that we will have x plus 4 and x minus 1 is equals to 0. So when we have that factor, so here you will have a mark for squaring both sides, a mark for standard form, and a mark for factorizing. Then now we have x is equals to -4 or x is equals to 1. So before you conclude as to which one is going to be the correct one for this one, what we need to do is to check which one is going to give us, like the left hand side and the right hand side being equal. So we substitute by -4 in where there's x. So here it's 5 minus, open bracket, -4, which is 5 plus 4, which is 9. And then the square root of 9, it is 3. And then again here, it's going to be positive 4 because of that negative. So it will be 3 plus 4 minus 1. So 3 plus 4 is 7 minus 1 is 6. So it means this one is not going to give us a 0. So then we take it out. And then now we come and then now we substitute the 1. So positive 1. So it's 5 minus 1, which is 4. And then the square root of 4, it is 2. And then here again, it is 1. So it's 2 minus 1, which is 1 minus 1, which is 0. So this one is the correct one for that. Then we will say x is not equals to -4 or x is equals to 1. So that is how we work it out. So with that one, you will get a mark for saying x is dead and x is dead. And another mark for making sure that the one which is not giving us the correct solution there, it's cancelled out. In this case, happened to be -4. So that is how this type of problems can be dealt with. In most cases, you find that the square root is one side, and then all other terms that are without the square root are on one side. So what you do, you just square both sides, and then you work it out, then up to get there. So when you are there, then you have what at least the solution means. So then we're going back to that 2017 question 1. So then the other one that comes in most cases in this 2017, then the next one was simultaneous equation. Then because that is part of question 1. So in this case, the simultaneous equation that was given, it was, they were saying solve for x and y. So that is 1.2. So we have to solve for x and y. So they've given us 3x minus y, it's equals to 4. And the other equation. So this one, we can name it equation 1. And then the other equation, which is x squared plus 2xy minus y squared is equals to -2. We can name this equation 2. So when we name it equation 2, then it means that now we can have 1 as the subject of the formula. So in these two equations, the first equation is the simpler one, to take one of the variable and make it the subject of the formula. And in this case, we can just say from equation 1. So what are we having in equation 1? We have 3x and then minus 1. So 3x, if we want to make x the subject of the formula, it means we have to divide by 3 every term, which will complicate our matters. So we will have -y, it's equal to -3x plus 4. So but we want y to be, like to say y it's equal to. So we divide by -1, -1, -1. So we have y it's equal to 3x minus 4. So we can name this now equation 3. So you get a mark for making one of the variables the subject of the formula. In this case, y is the subject of the formula. Then that is where the first mark comes in. The second mark comes in when you now substitute this equation, the newly formed equation, into the other equation which you did not fiddle with. So in this case, the equation 2, we did not do anything to it. So it means now we will say substitute equation 3 into equation 2. So when we substitute equation 3 into equation 2, it means that wherever there is y, we no longer write y, but we write 3x minus 4, because 3x minus 4 is equals to y. So where there's y, so we are eliminating y now, so that we remain with x's. So we are having x squared plus 2x into, so where there's y, we no longer write y, but we write 3x minus 4 minus, we open up the bracket, again it was supposed to be y squared, so it's 3x minus 4 squared, and then now we still have the negative 2 there, so we just transpose it, it will be plus 2 is equal to 0. So then we now have to simplify that those terms there. So we will have x squared, and then now plus 2x times 3x, it will give us 6x squared. Again, we are using the distributive law. We'll say 2x times negative 4, which will give us negative 8x. And then this one, it means we are writing it twice, so we'll still have the negative so that we don't get ourselves confused. Then, now, it means that it is 3x minus 4 into 3x minus 4. So 3x times 3x, it's 9x squared. And then 3x times 4, or 3x times negative 4, will give us the negative 12, which will give us negative 24x. And then the negative 4 times negative 4, it's 16. Then we still have plus 2, it's equals to 0. Then we are now going on now to simplify everything so that we have it in standard form. So we are having x squared plus 6x squared, which is 7x squared. 7x squared, and then we still have negative 8x. So this and this is negative 9x squared, and then positive 24x, because that's negative times negative there. And then negative times that is negative 16 plus 2, it's equals to 0. So now we are now finalizing our simplification, where we have 7x minus 7x squared minus 9x squared. So we are having minus 2x squared. So if we're having negative 2x squared, and then now we have the x and the x there. So 24x minus 8, we are going to have positive 16x. And then now we go for negative 16 and the 2 there, which is negative 14 is equals to 0. So you will get another mark for the standard form there. But in this one, we have, in each and every term, we have a common factor, which is 2. So it means for us to work it out nicely, we can divide by negative 2, negative 2, negative 2, negative 2, each and every term. So we are going to have x squared minus 8x plus 7 is equals to 0. Because 16 divided by 2 is 8, 14 divided by 2 is 7, but negative and negative is positive, positive and negative is negative, negative and negative is positive there. So that is what we are having. So the factors, because of the last term is positive and then the middle term is negative. So it means the factors there are going to be negative, both of them. So it's negative 7 and negative 1 is equals to 0. So then what we are having now, we are having x is equals to 7 or x is equals to 1. So you get a mark for standard form, you get a mark for factorization, you get 1 mark for both correct values of x. And then now, we are not yet done because we have to solve for x and 1. Now we have solved for x, we have to solve for 1. So what we need to do is just to say therefore, because like from equation 3 is the one that is simplified as y is equals to. So we substitute the value of x in that equation to get the values of 1. So it's y is equals to 3 into 7 minus 4, or y is equals to 3 into 1 minus 4. Where we have y is equals to 3 times 7 is 21, and then 21 minus 4, it's 17, or y it equals to 3 times 1 is 3, 3 minus 4, it's negative 1. So then now we have solved our simultaneous equation, or the values of x and y. So now we have the y is equals to 17 and 1. So meaning that these two equations, or these two functions, or these two graphs, they intersect at x is 7 and y is 17, and where x is 1 and then y is negative 1. So that is the 2 points in which those two graphs intersect. They intersect x when x is 7, y is 17, when x is 1 and then y is negative 1. So that is how generally we deal or we solve the simultaneous equation. So simultaneous equation is dealt in such a way that you just do it that way. So then that is one way of dealing with it, or that is generally we deal with it. You will be given two equations with x and y in most cases, or any other two different variables. And then now, when you are having those two equations, and then now from one equation you make one of the variables the subject of the formula. In this case we make y the subject of the formula. Then you start substituting, you work it out, you find the standard form, you factorize, you find the values, and then after finding the values you substitute those values in the simpler equation to get it as you want it. So that is how this paper came for that particular year in 2017. And they were like 1.3. The given equation, which was f of x is equals to x squared plus 8x plus 16. So then that is what was given. So now in 1.3.1, and then the question came, and then they said solve for x. For x solve for x if f of x is greater than 0. So that is what we are having there. So then they said solve for x if f of x is greater than 0. So this one, it's all about the inequality. So what is our f of x? Our f of x, it's x squared plus 8x plus 16 is greater than 0, because that is equal to f of x. So it means, in short, they were saying this is what we have to do. We have to have the x squared plus 8x plus 16. That one must give us greater than 0. So what we are having, the x squared is just x squared. So the factors of x squared there is just x and x in this case. X and x. And then now we have to come for the factors of 16. Factors of 16 in pairs, they are quite a number. In this case, we can write them as, so that we see which one will give us the middle term. In this case, the pairs, it's 1 and 16. So 1 and 16, because of it's positive and positive there, so both of them should be positive. When you add, it will give us 17. We also have 2 and 8. When we add, it will give us a 10. We also have 4 and 4. When we add, it will give us, that 8 that they want there. So this is, in short, it's a perfect square. So we are having x plus 4 and x plus 4 is greater than 0. So when we have it in that way, so now it means that when we have this, it means that the critical values is just going to be x is equals to negative 4. So if x x is greater than negative, if it's equals to -4, then we have to substitute this in a rough sketch. So that -4, it means that it's where it's gonna turn. Then it's gonna be like that, our rough sketch. So then they are saying where it's greater than 0. So greater than 0, so here at the origin, that is why we are having the 0. So this 0 is the y0. So if it's the y0 and then they say greater than 0, in short they are saying when you substitute that value here, the answer should always be positive. So then it means that if ever there's anything that is coming before -4, it's giving us the positive values because they are above the 0. So the negative values are the ones that are below the 0. So in this case, then that is what we're having there, the -4. So now, if that is the rough sketch and it's greater than 0, so in this case, this graph or this sketch, there's nothing that will give us less than 0. It's just going to give us equals to 0 or greater than 0. In, like for an example, if we can just substitute by -5 here, and then there it will be 25, and then here it's going to be -40. Then so 25 plus 16, it's going to be 25 plus 16. It's going to be 41. So it means that the answer there is going to be 1, which is going to be correct here. And also, if we can substitute by -3. So if it's -3 here, then here it's going to be 9, and then here is going to be -24. So 9 plus 16 is 25. So 25 minus 24, it's 1. So again, it's going to be positive. So then, it means now, when we conclude our this solution that we are working on here, we can just say x is greater than -4 again, or x is less than -4, because both are giving us what we want. So then whatever that goes there, the greater than and the less than, they are giving us what we want. So then that is how this solution is worked out. There's a mark for the critical value, and that critical value in most cases, if you can substitute it in the sketch or a rough sketch, then that is when the marker will just see it clearly than just to leave it in that way. So that is how this one should be dealt with. And then now, so that is what we are having. Then 1.3.2, they are saying, for which values of p will f of x, which values of p will f of x equals to p will have 2 unequal negative roots. 2 unequal negative roots. So in this case, we are dealing with the nature of roots. When we deal with the nature of roots, we know that the nature of roots, we do have the roots that are equal, we do have the roots that are not equal but rational, we do have the roots that are not equal and irrational, we do have the roots that are non-real. So then, but here, they are saying this f of x is equals to p must give us the roots that are unequal and negative. So we can come back to this sketch. If we come back to this sketch, it means as it is now, or maybe if we can just come back there. As it is now, it's having only one root at -4. That one root, it means the roots are equal because that was a perfect square. So now, if ever we shift this line going up, it means that now it will have 2 roots. It will have a root somewhere there and a root here. So then it means that those roots are 2 and they are still negative up until when we get here. When we get here, it means one root is negative and then the other root is 0. So it means that, and here, it's where we are having our 16. So it means that this sketch should shift, or this line should shift up until 16. It cannot, if it goes beyond 16, it means that now, if it goes beyond 16, now, it means that one root will be positive and the other root will be negative. So then they are saying we should have those roots that are unequal, and both roots should be negative roots. So the f of x is still the same as that x squared there. So we are now going to solve this using the nature of roots. So meaning that in one equation, we are dealing with two concepts. One concept is the inequality, and then the other concept is what we call the nature of roots. So then 1.3.2 f of x is equals to p, which in this case happen to be x squared plus 8x plus 16 is equals to p. Then transpose the p, so we are having x squared plus 8x plus 16 minus p is equals to 0. So now, when the roots have to be negative, we know that we are saying it should not go above 16. It means it should be just there at the 16. So what we can do is, this is A, this is B, both the 16 and the minus P, those are our C. So we are using the B squared, or the discriminant, B squared minus 4AC. Then for unequal roots, it means that we are talking about greater than 0. So then, what are we doing here? It means the B, it's our 8. So which is 8 squared minus 4. Our A is 1. But our C, 16 minus P greater than 0. So we are having 64. And then now, with the negative of 1, like negative 4 times 1 is negative 4. So negative 4 times 16, it's negative 64. Then now we come to say negative 4 times negative p, which is positive 4p, should be greater than 0. So then here the 64 minus 64 is going to give us a 0. So it means that here we are having 4p greater than 0, whereby when we divide by 4, we'll have p greater than 0. But we know that it cannot, even though it has to be greater than 0, but it will not, to limit it to two roots that are different and are still negative roots. It means that it cannot go beyond 0. Then we say, but p cannot be greater than 16. So that is the solution that we are having there for this one, for this nature of roots. So nature of roots, like one, you have to remember that we are talking about when roots are equal, we talk about the perfect square. But if roots are not equal and they are rational, it means that the value of the discriminant is, the answer for that discriminant, it's a square number. Square numbers, we talk about 1, we talk about 4, we talk about 9, and stuff like that. So then if the answer for the discriminant is a square number, then it means the roots are not equal, but they are rational. But if the answer or the value of the discriminant is a non-square number, then it means, but positive, it means that the roots are not equal and they are irrational. But if now the answer or the solution to the discriminant is negative number or negative any number, then it means that the roots are non-real. Because remember, if we are using this, because this one, it's within the square root of the quadratic equation, then if it's the negative in the square root, then it means that root, the roots of that particular equation or that particular graph, they don't exist. So that is why I would say those are non-real. So then that is how we deal with the nature of roots. But I want us to go back to inequality again and see how inequality comes, so that at least when we are dealing with the inequalities, then we don't have a problem. So that is how we have to look into that, so that at least we will be done with the question 1 of paper 1 in mathematics, the paper that, the question that has plus minus 25 marks in most cases, and those are the lot of marks. So I want us to take a look at the inequality. So the other inequality that we may have it x minus 3 and x minus 3 is less than or equals to 25. So the inequality sometimes it may come in that format or in any other format, but what we need to do again, we need to make sure that this one it's rewritten in standard form. So how do we rewrite it in standard form? We make sure that we find the products of those values in the brackets there. So the product there, we're going to have x times x, which is x squared. And then we say x times negative 3, which is negative 3x. Negative 3 times x, negative 3x. Negative 3 times negative 3 is positive 9. We transpose 25, which is negative 25, less than or equals to 0. So then here we are going to have x squared minus 6x. And then now the 9 minus 24, we are going to have negative 16, which is less than or equals to 0. So then if it comes in this way, the first mark for this inequality will just come in the standard form. The standard form, which is the ax squared plus bx plus c, and then now. So we have to factorize this one. So the factors of 16 in pairs, again, because here the factors will just be x and x. So we can just write them x and x. So it's less than or equals to 0. Then the factors of 16, we have, like I think we spoke about it, we have 1 and 16. So if we're having 1 and 16, because it's negative, then it means one should be positive, the other one should be negative. Then are we going to get the 6 that may determine the 1? If it's 1 and 16, because 1 times 16, it's 16. So then because of the negative, it means subtraction. So 16 minus 1, it's 15. Then we come to 2 and 8, and then 4 and 4. So but 2 and 8, 8 minus 2 is 6. So then we have found our factors that we need here. So we are having 8 and 2. Then because of the negative there, it's negative here, and it's positive here. Because 8 is bigger than 2, so then the bigger one takes the sign of the middle term, so then that is what we're having. Then, now, our critical values are x is equal to 8, or x is equal to negative 2. Then, these critical values, we must show them in a rough sketch. So in this case, it happened to be negative 2, and then 8. So it's less than. So less than, we talk about this region here, which is below the 0 there. Those ones, that is what we are dealing with. So that region, it means any value greater than negative 2 will give us anything in that region, or any value that is less than 8, it will give us anything within that region there. So then it means that when we conclude, we will say x should be greater than or equals to negative 2, or x should be less than or equals to 8. And of which this one, you can also substitute it in this notation, whereby we say it's x and then 8. Like negative 2 is less than x and x is less than 8. Then this is the, if it's less than, is the one that we can use that notation. But if it's greater than, because why do we use that one there? It's because if we use the number line, where we have negative 2 and we have 8, and then we say that one and that one, because of the equal sign, it means this dot will be shaded, and then that dot will be shaded. So we are having the arrow that goes this way and the arrow that goes that way. So those arrows, they meet. So then that is where we have it just like this. So then that is why that notation can be used, because these ones, they connect, they come together in there. And then we can just take another one, maybe with greater than, and see how the number line, because if sometimes they show that in the number line, sometimes these things are confusing. So if it's in the number line, greater than negative 2, it's going this way, less than 8 is going this way, so then they meet. So that is why they join there. So if maybe we have x squared plus 4x minus 12 is greater than 0. So let's say we are having it in that way. So this one is already in standard form. So if it's in standard form, then there's no need for us to rewrite it otherwise, because it's in standard form. So the only step that we need to take from here is just to say it's x and then x, then greater than. So then the factors of 12, which will give us 4, is 2 and 6. And then that one is positive, so 6 will be positive, 2 will be negative, because the sign there is negative. So it means that the factors, one should be positive, the other one should be negative. Then that is how we deal with it. So because of the greater than, then the critical values, we're having x is 2 or x is negative 6. Then you remember, like we spoke about that one, like transposing and then become positive, become negative. So then in a rough sketch for this one, it means that because of the positive there, and then it is like that, whereby here is negative 6 and then here is 2. So if it's like that, then we are saying it's greater than. So where is the greater than? So we are talking about this region here and that region there. So because anything or any value which is there, then it will give us anything in that region and anything in that region. So greater than 0, we talk about anything above 0, which is positive, and anything less than 0, which is negative in this case. So now, if it's like that, and then how do we now write it in that way? So we will say any x which is greater than negative 6, or x which is less than. No? When we conclude in this one, because of the greater than there, it means anything that is less than negative 6 and anything that is greater than 2, then are the ones that are going to give us what we want. So when we use the number line, it's negative, it's positive. So then, because of there is no equal sign here, it's just greater than. So it means we leave those little circles open. So then, because of it's less than, and then this one, it's going this way, this one is going that way. So then that is how you show this in the number line. In a sketch, that's how it is, and then in the number line, that is how we show it. So you show it in the number line in that way, and then you show it in the sketch in that way, because that is the greater than, and then the greater than. And then here, it's going this way because it's greater than 2, and then it's going that way because it's less than negative 6. So that is how these things, or the question 1, paper 1, it's dealt with, or how you can work it out. So the more you practice, is the more you get it right. Because if you don't practice, then you always forget. So then if you can keep on practicing, because normally, whether it is the factorization, whether it is the inequalities, whether it's the quadratic equation, and then it boils back to the general quadratic equations, which in this case we are dealing with the trinomials, whereby we have the x squared, the x, and then the constant. Then that is how these things are dealt with. This was paper 1, chapter 1, question 1, so to say. Then next week we are, instead of just going through the previous paper, we are going to do the analytical geometry, because it's one of the topics that people can get good marks in paper 2. So come prepared for analytical geometry. We will try within an hour to do what we can. If ever we don't finish, then the other lesson will come up with, or we'll complete it. Then, but if you are having questions concerning what we're doing today, you can forward them in that Facebook, or you can forward them in the WhatsApp that you'll be given, so that next week, Tuesday, before we continue with analytical geometry, we will try to answer those questions that you will be having. Thank you very much.